All right, here we go with some more solution stoichiometry. So this is one of the questions that I wrote up for additional practice and probably linked, like you probably found this video because I linked it with the quiz review. So this is ahead of our solution stoichiometry quiz, that big scary quiz. And I think this question, in terms of the formatting, is like really similar to what you should expect for the quiz, right? So we have a big question stem, a lot of information, and then parts A, B, C, D, E, F, G in this case. And the way that I have like structured the question, you're kind of using like part A to do part B feeds into part C. You know, like the parts like are kind of related to each other. And I tend to do that a lot for AT Chem questions to kind of scaffold it for you. And also like it's easy to grade that way. So, okay. So we've got 30 milliliters of 0.53 molar lead 2 nitrate solution. We're going to combine that with 60 milliliters of potassium iodide solution that has an unknown concentration. We get a yellow precipitate of 3.5 grams. Okay, we're going to take that precipitate out, so we're going to filter it out. There's still some solution left in there. We're going to add excess sodium carbonate and another precipitate forms. We get a white precipitate formed. We take out the white precipitate, filter it out, and then dry it to get rid of the water. All right, what should we look at for the phrasing of this question? So this word right here stands out to me, right? And I guess it should because I wrote this question. Excess, right? So what does that mean? That means that we added a lot of sodium carbonate in that second step, right? So there are two precipitation reactions happening. I'm actually going to talk about these and write these here, and then we'll go look at my other work for like B, C, D, E, F, G. But for the precipitation reactions, let's talk about them. So we've got a lead compound, right? That's our lead cation, lead 2, reacting with the potassium iodide. So that first precipitate must be lead 2 iodide, right? Because the potassium won't precipitate and the nitrate won't precipitate ever. We will never see potassium or nitrate as a precipitate in one of these questions. So that first precipitation reaction, I'm going to write it here, is lead 2 plus 2 iodide gives us lead 2 iodide, PbI2. And if you look at your list of solubility rules, lead is one of the exceptions. Lead 2 is one of the exceptions for the halide rule, right? So it's like all salts of chloride, bromide, and iodide are soluble except for silver, lead, and then mercury is the other one, right? So that's our first solid. Right? We're going to filter out whatever solid was produced. And this is yellow, by the way. This is another interesting question about, or an interesting kind of part about this question. I don't expect you to know that this is a yellow solid, but this is one of the precipitates that's actually not white. So that's another clue. We actually do that precipitation reaction in 10th grade. So it's a little Easter egg in there, where you mix actually lead nitrate and potassium iodide, and you make a yellow precipitate. So if you knew that that was yellow anyway, that's kind of like another hint for you. Anyway, you didn't need to know that, but that's kind of fun. Okay, so second part of the question is we're going to add excess sodium carbonate, and we get another precipitate. Okay, so then again we have to like ask, well, what else would precipitate here? Again, none of the sodium salts are going to precipitate. None of the potassium salts are going to precipitate. The nitrate doesn't precipitate. So what is that other thing that precipitated? Well, it must be lead again, right? Lead back for round 2, this time with the carbonate. Now, I've had a lot of people ask, like, well, how, should I know that not all the lead precipitated in that first step? And my answer to that question is because there's another precipitate that's formed. That's the only thing that can form, right? That's the only thing that'll precipitate out of this is that lead carbonate. Because your other things, your nitrate, your potassium, your sodium, those are just classic spectator ions, right? Those are just spectator ion role players, right? We're never going to see them do anything other than spectate in these precipitation reactions. So because we're getting a second precipitate forming, that must mean that there's still some lead left in solution, right? This first step where we make the lead iodide, that is not a complete precipitation of lead. There still had to be some lead left to make this lead 2 carbonate here. Okay? All right, so now that we've got our net ionics written, we are going to go look at the calculations part of this, right? B, C, D, E, F, G. And I'm just going to like show my solutions and talk through those. So yeah, let's head over to the next slide and we'll do that. All right, so much work, I can't fit it all on the screen, but here we go. Here's A, B, and C. So we talked about how we arrived at our precipitation reactions. Okay. The second question was how many moles of lead reacted to form that first precipitate? Well, in the problem, I tell you that there's 3.5 grams of that precipitate. We figured out that it was lead to iodide. So this is just a grams to moles conversion. 461 is the molar mass of lead to iodide. And then I'm going to moles of lead. So this is the ratio of the ion to the compound, right? There's 1 Pb and a PbI2. So it's 1 to 1. And we figure out how many moles of lead we've got, right? So we take the mass of the compound, mass of the precipitate, convert it to moles, do the ratio. There we go. All right. Question C, how many moles of lead reacted to form the second compound? All right. This is kind of back to that idea of like what was like remaining after the first precipitate is what was initially there minus what precipitated, right? So like when we do those questions about calculating ion concentration, I always, or like I've said that you can figure out what remains by doing initial minus precipitated. So we're taking that idea, right? I know what was initially present. I can get that by concentration times volume, 0.0159 moles of lead initially. And then I'm going to subtract from that the moles that came out in precipitate 1. Now, the reason that I know that this is the moles that were in precipitate 2, right, because the question is how many moles reacted to form that second precipitate, is again back to that word. Such an important word for us as we learn more about stoichiometry and AT chemistry. And that's excess, right? So because we're adding excess sodium carbonate, that means that we are forcing this lead to be limiting, right? We are adding so much. Let's go up and look at our net ionic equation. We're adding so much of this carbonate, right? This is our excess here. We're adding so much of our excess that it forces lead to be limiting, right? We are precipitating all of that lead. So I know that all the lead's coming out in precipitate number 2. And so whatever was left over, whatever didn't react to form precipitate 1, must be what's in precipitate 2, right? So again, back to that idea of like what remains in solution. That's essentially what we're doing here. Just a little bit of a different flavor there, all right? Now, before we go on and we look at the next parts, see how we're taking our answer from, our answer from part A, we figured out it was lead iodide. That plays in here, so we can get the molar mass. We get a number of moles. And you see how we're using that answer down here? See how part A is linked to part B, linked to part C, right? Get used to that. We do that a lot in AT chemistry. It is all error carry forward, but we got to be able to like kind of chip away at these big problems. All right, let's go look at the next part. Okay, part D and part E. So in part D, in question D, I ask you what is the mass of that white precipitate? Here's our answer from part C, right? That's what we just figured out. Let's go to the mass. We know that it's lead carbonate. We figured that out. In part A, it's a 1-to-1 ratio, lead to lead carbonate. And then here's the molar mass of lead carbonate, 2.22 grams PbCO3. That must be the mass of that precipitate, okay? Again, notice how part C feeds into part D. And then this is essentially just a grams to moles conversion. So the math here, right, we've done this. You did this in 10th grade. Everybody's so good at that, right? But you got to like read that question and kind of know sort of like, what direction we're headed in. That's the challenge here. All right, part E. What is the concentration of lead ions in solution after the first precipitate? Okay, so first our total volume is 90 milliliters because we have 30 milliliters of the lead solution and then 60 milliliters of the potassium solution, right? Moles left over after that first precipitation. So here's what we had initially. We figured this out in part C. Here's what precipitated in that first precipitate. So this was the number of moles left over there after that first precipitation reaction. All right, now you might look at that and say, well, like, didn't we just calculate that in part C? Because we calculated like how many moles reacted to form precipitate 2? Yes. Again, the design of the question is not to trip you up on the calculations, but it's to make you think about what the question's asking you, right? This is the same calculation or the same question that I asked in part C. It's just phrased a different way. So you have the same number of moles of lead left in solution after the first precipitate, before we add that lead, before we add the sodium carbonate. Same idea here, all right? We're going to take that number of moles, put it over the 90 milliliters. This tells us our concentration of lead before that sodium carbonate was added, before that second precipitate was formed, okay? So very similar numerically to part C, right? They're cousins, but question was phrased a little bit differently. And again, we're getting practice on reading this question and thinking about, well, what is this asking me and how can I access those numbers, right? That's what we're looking for. Okay, we have 2 parts left. Let's hop over and look at those. All right, question F, the classic. What is the concentration of lead ions in solution after the second precipitate is formed, right? So after we add that lead carbonate. It is 0 molar. We don't have to do any math, right? We know that since we're adding excess sodium carbonate, we're assuming all that lead precipitates, right? Lead's the limiting reactant, so 0 molar. Now let's say you went through and like you did that, right? So you're going to figure out how much lead was there initially to like form that second precipitate. That is our answer from part C. And then you could figure out, like, based on the mass of the white precipitate, right? Part D, you could like do the subtraction of moles and you get 0, right? It comes out 0. Lead's limiting. Okay. Again, the key word, we don't have to do any of those calculations. The key word in the problem is when I said we're going to add excess sodium carbonate, right? That's what we're looking for. All right. And then lastly, part G. What's the concentration of nitrate ions after the first precipitate is formed? Nitrate, always a spectator. There is never an instance when nitrate is not a spectator ion in a precipitation reaction, right? It just never precipitates. It's always going to be a spectator. So the moles of nitrate in solution doesn't change. Whatever was there before all this precipitation happened is going to be the same after all the precipitation happened. So we just got to figure out how much we had, right? Came from the lead nitrate solution, so we're doing the concentration of the lead nitrate times the volume of the lead nitrate solution. We get 0.0159 moles of lead nitrate. It is a 2-to-1, right? Because it's lead 2 nitrate. So there's 2 nitrates in there. So 2-to-1, we got to double that. We put that over, ooh, that's a typo, right? And it's supposed to be over 90 milliliters, not 80. Uh-oh. I'll have to fix this on my answer sheets because I'm not re-recording this. 0.0900. Let me pause and recalculate. Okay, over 90 milliliters, not 80, because it's 60 mil of the potassium iodide solution and 30 mil of the lead nitrate solution. So 30 plus 60 is 90. Same idea though, right? Get our moles, recalculate. It's 0.353 molar should be that answer. I will update this on the answers that are linked to, yeah, but that's kind of a fun moment there where you get to see me fix a mistake in real time. Okay. That's a big problem. Again, I think in terms of structure, that is pretty similar to the quiz question, and we want to get comfortable with kind of the structure. Okay, so I hope that was helpful. I know that there's other problems on that worksheet. I'm going to link like separate videos for those. So if you got questions about like the other ones, go check out those videos.